Let us now learn about the relationship between the mass of a substance and the mole. Let us try to remind ourselves of what we already know. We know that 1 mole of a particle will contain 6.022 times 10 to the power of 23 of the particle. This tells us the relationship between mole and the number of atoms, or the number of molecules, or the number of ions. So particles means atoms, or molecules, or ions. What about the relationship between mass and mole? To answer that question, let us take a look at the periodic table. On the periodic table, you see the atomic masses of the elements at the bottom of each box. This is a definition of 1 mole that we now want to know. 1 mole of an atom is equal to the atomic mass of the atom, but in grams. Let me explain. What that means is that if, for example, I tell you to give me 1 mole of zinc atoms, if you look at the periodic table, what I'm saying is that you should give me 65.39 grams of zinc. If I tell you to give me 1 mole of mercury atoms, this is what I'm saying. Give me 200.59 grams of mercury. So 1 mole of an atom is equal to the atomic mass, which is found on the periodic table, just with the unit of grams. And examples will be, if I ask you to give me 1 mole of silicon, what I am saying is that take a look at silicon and give me about 28.09 grams. Now, I'm using 2 decimal places here because that is usually how we round the atomic masses in the periodic table. One more example. 1 mole of silver. Take a look at the periodic table. Here is silver. Round to 2 decimal places. That will be 107.87. 107.87 grams. Let us now answer this question. What mass of platinum is equal to 0.025 moles? The very first thing to try to do is to understand what you know and what you don't know. In this question, we want to find the mass. That is what we do not know. But what do we know? We know the mole. Is there a direct relationship between mass and mole? Yes, but to know that relationship, we need to know the identity of the substance we are dealing with. And in this question, we are dealing with platinum. That identity can allow us to know the relationship between the mass and the mole. Because for platinum, and we're going to need the periodic table, for platinum, 1 mole of platinum would have a mass of 195.08 grams approximately. 1 mole of platinum will have a mass of 195.08 grams. That is the relationship between the mole of platinum and the mass. So we have a direct relationship between what we want and what we know. We can make use of that relationship as a conversion factor. So if you have 0.025 moles of platinum, all you need to do is multiply by the relationship between the two. In this case, 1 mole of platinum will normally have a mass of 195.08 grams. Moles will cancel out. And then if you punch this into your calculator, you should get 4.877 grams, which we then round to 2 significant figures based on the measurements given to us as 4.9 grams. This means that we now know how to go from moles to mass if we were supplied the moles. Let us take a look at another question where we will need to convert mass to moles. In this question, we want to know how many moles of sodium will have a mass of 46.0 grams. So we want to find moles. We know the mass and we know the identity of the substance we're dealing with. Since we're dealing with sodium, if you take a look at the periodic table, sodium has atomic mass of 22.99 rounded to 2 decimal places. That means that 1 mole of sodium will have a mass of 22.99 grams. This will be the relationship between 1 mole and the mass of sodium, and that will be used as a conversion factor. Which means that if you have 46.0 grams of sodium, as given in the question, all you need to do is to multiply by the conversion factor, which says that 22.99 grams of sodium is normally equal to 1 mole. If you cancel out the grams of sodium and you punch the numbers into your calculators, you should get approximately 2.00 mole if you round to 3 significant figures. Let us now take a look at one very simple question that comes out of the relationship between the mass and the mole. Take a look at this question. What is the mass of 1 mole of carbon dioxide? Carbon dioxide has a formula of CO2. We want to know the mass of 1 mole of carbon dioxide. That means we should look at the periodic table and add up all the atomic masses in the formula. On the periodic table, carbon is approximately 12.01, oxygen is approximately 16.00. So the mass of 1 mole of carbon dioxide will be 12.01 plus 2 multiplied by 16.00 for oxygen, and that should add up to 44.01 grams for 1 mole per mole. This mass of 1 mole has another name, and that is what I actually want you to know right now. Mass of 1 mole is also called molar mass, which means that 44.01 gram per mole is the molar mass for carbon dioxide, and it has a unit of gram per mole. So anytime you see gram per mole, which is another way of saying mass of 1 mole or molar mass, you now know what to do. To be sure that you get the concept of molar mass, let us answer this question together. Calculate the molar mass for lithium carbonate. In this question, the formula is given. In many other questions, the formula will not be given. So you would be the one to use your knowledge of nomenclature to write the formula for the compound. And lithium carbonate is used to treat bipolar disorder. So we want to know the molar mass of Li2CO3, which means we need to have a copy of the periodic table. On the periodic table, lithium is 6.94, rounded to 2 decimal places. We have 2 atoms of lithium in the formula, so we multiply by 2. On the periodic table, carbon is 12.01, rounded to 2 decimal places. We only have 1 atom of carbon, and we have 3 atoms of oxygen. Each oxygen atom has atomic mass of 16.00, and since there are 3 of them, we multiply by 3. If you multiply and add everything, you should get 73.89, and the unit should be gram per mole, which means mass of 1 mole. Let us now take a look at another question. This time we want to use multiple conversion factors. How many molecules of H2O are in a sample of water with a mass of 3.64 grams? We want to find how many molecules, which means we are going to need the Avogadro's number, because if you want to count molecules, you should expect to get a very big number. But what do we know? We only know the mass. Do we have a direct relationship between number of molecules and mass? No, we do not. However, The mass supplied to us, we can convert it to moles and then convert the moles to the number of molecules. How are we going to be able to do this? The relationship between mass and moles, we know the relationship. 1 mole of an atom will be equal to the atomic mass of the atom in grams. The relationship between moles and number of molecules, we know that as well. We know that 1 mole of a substance will contain 6.022 times 10 to the power of 23 molecules. So for this question, we will first convert the mass of water given to us to the mole and then to the number of molecules. Let us write the 2 conversion factors we need. We know that 1 mole of water will have a mass of 18.02 grams. That is the molar mass of water. Because in the periodic table, hydrogen has a mass of 1.01 multiplied by 2 because we have 2 atoms, plus the atomic mass of oxygen on the periodic table is 16.00. That works out to 18.02 gram per mole. We can now easily go from the mass to the number of molecules. So if we have 3.64 grams of water, we can use the first conversion factor, which is to change the grams to mole. We know the conversion factor, 18.02 grams of water is equal to 1 mole of water. Grams of water will cancel out. Then we multiply by the second conversion factor. We know that 1 mole of water will normally contain 6.022 times 10 to the power of 23 molecules of water. Moles of water will cancel out. If you plug all of these numbers into your calculator, you should get 1.216 43 times 10 to the power of 23 molecules of water. And this rounded to 3 significant figures based on the measurement provided to us should be equal to 1.22 times 10 to the power of 23 molecules. Let us now take a look at another question that is similar in concept to what we just did. What mass of silica, SiO2, used in computer processors contains 5.19 times 10 to the power 21 formula units? Formula units is being used here to represent individual molecule. We want to find the mass. We know how many molecules. So How can we go from the formula units to the mass? We know the number of formula units, or think of it as number of molecules. We can convert that to moles. We know the relationship that is needed to make that conversion. We know that 1 mole will contain 6.022 times 10 to the power of 23 formula units. And then we can change the mole to mass. We know that 1 mole will be equal to the molar mass in grams. So let us begin with 5.19 times 10 to the power of 21 formula units of SiO2. We can change that to mole if we multiply by the conversion factor, which says that 6.022 times 10 to the power 23 formula units of SiO2 will normally be equal to 1 mole of SiO2. Then we cancel out formula units. We can then change the mole to the mass, but we will need first to know the molar mass of SiO2. From the periodic table, silicon is 28.09 and oxygen is 16.00. We have 2 atoms of oxygen. If you add up everything, you should get 60.09 gram per mole. So the conversion factor here will be 1 mole of silica will normally have a mass of 60.09 grams, and moles of silica will cancel out, and your calculator will complete the rest. You should get 0.517876 grams of SiO2, which if you round to 3 significant figures based on the measurement given to you should be 0.518 grams of SiO2.